Hello everyone, welcome to the session. Today's guys, I'm audible. Yeah.
Yeah, you're
Okay, let's share my screen. Is my screen visible for you guys?
yeah, it's visible.
Okay. So till yesterday we have been learned about LLM evaluation. So after LLM evaluation, there is one more important concept, which is RAG. So it is very hot topic in the market. RAG, R-A-G. So does anyone have any idea about RAG? What is RAG or any definition from your side? Yes or no, maybe?
No, Jan, not much.
Oh, okay. So till now, what we have seen in the LLMs. So LLMs where from there we are getting the answers. We are able to generate the answers. We are cross-checking like is the answer is correct or not. From the LLM side, we are validating. Now what the picture from what exactly LLM is doing is that LLM has a large set of database. From that database, it is giving the answer as per understanding using transformers, machine learning. The key capabilities is having that, and it will generate the answers. But what exactly it is leading to hallucinations. So to eradicate that hallucinations, there is one more powerful tool is called RAG. So the RAG will work as it will eradicate the hallucinations. We are going to learn how it will eradicate. So first, let's see the definition of RAG. RAG is like retrieval, augmentation, and generation. This is a definition. Mostly RAG depends on retrieval strategy. So in the LLM, we will get the answer. But if you ask where is the ground truth, on what basis you are saying that this is the correct answer, for LLM there is no answer for that. It will generate the answer, but it is not sure whether it is correct or hallucinated or something. Even though we are having the metrics, LLM evaluation metrics, but not 100% it is going to help us. But with the RAG, it will help you. So before starting into the RAG, we need to understand the history of RAG, why it has been came into the picture. Before the era of RAG, LLMs, everything, there is a thing. Is anyone joining? Okay. Before the era of RAG, LLM testing, everything, there is a basic thing, which is keyword search. So we are all familiar with keyword search, right? What exactly it will do? If you ask any question like what is the capital something something, you will ask a question. So now consider that we are having n number of data in database, some lakhs of data documents. What it will do exactly, the keyword search is it will do the matching with what is the capital. Randomly it will cross check everything and it is going to generate the results like on top of 1 lakh documents. Maybe when you have been seen clearly in the Google search initial days when you have been started your career, when you are making a search, you are going to get the answer. Along with that, you are going to see similar kind of results like 1,000 results, 1,500 results, 2,000 results, 100 results. Like why? because initially the Google search is depends on keyword search. On the same formula, the ChatGPT has been designed first of all in such a way, and we have done the keyword search. But when it comes to companies, okay, when it to come to companies, they are having some large set of data. Consider that 1 lakh documents are there in that. They want to make a search. But what happens when they are making 1 lakh data? So they are going to get similar kind of answers, but which is not going to give the top answer. Suppose if I am teaching like I am a considered social person or like very interested about the nations. If I ask what is the capital of India, because the data is completely trained on like countries and its capitals. So most of the score, everything will match here. What is the words, keywords. So now what we are going to get? Nothing. It is going to get the match. Something if you ask what is the capital of India, it may give Uganda or America. It's a hallucination somewhere because it is doing the comparison of keywords and it is giving the answers. So system completely fails on the keyword search. Okay. Then after that, what came? After keyword search, we came into the evolution of second one is semantic search. We already learned what is semantic search. So the semantic search is nothing but a vector search. What it will use to do, it will take the customer's data and now it will keep it in a DB and it will convert everything into vectors as a embeddings. I will show you how it will look like. Now what will change is like instead of matching words in the keyword search, instead of matching words like keyword search, uh, it will the system will understand meaning using embeddings. It will understand using embeddings. Okay, so someone has been asked how the embeddings will be way of how we are going to see the embeddings. Someone has asked like there is like one opening in the job opening for embedding search like vector search in the DB. So I will show you how it will looks like. Okay. Mm, yeah. So consider this is the database table. Okay. In this database table, this is our project. In this, we are having SQL editors. When we are running our queries, we are going to get our data from the tables. When we are running the chunks, I will explain. Just understand only how the embeddings will look into that. This is the context, the chunk, how it is. The chunk is like software testing. I have been loaded one document. This is a chunk I have been extracted. Okay. How the embedding is going to look like. Edit row. See, this is the way, the structure what we have seen. The first one is like what the chunk it is. Now how it has been converted into vector search, which is nothing but embeddings. Everything is in numbers. Clear for this one?
So is this a database?
Yes, it's a database.
Okay, so what's the name of the database?
PostgreSQL.
Okay.
Supabase.com, PostgreSQL it will support. From where we can design this table. I mean, like one project. From there, you can create your SQL editor. From there, we can convert it.
Can you share the link of this as well so that I can have on the Google Drive basically, so we can just have a play around with this.
Yeah, sure, definitely. We'll share
Thank
that.
you.
Yeah. Okay. Now, where are we here? Yeah. we are storing the data in embeddings. How the embeddings will do, as we discussed previously, the embeddings will, which is a three pictorial, it's like a 3D pictorial diagram. In this, which is having the nearest neighbor algorithms, it will map to the particular document. So if the user asks one question, it will map that entire question into a embeddings vector search. And again, the data here it will convert into vectors. It will match which is having the nearest score, and it will be pushed on top of that. What is the answer? Okay. So till now, just understand about these are the vectors. Now, so in this embeddings, we are going to use, if we want to compare, make a comparison, we have been already learned what it will use. It may use cosine similarity or semantic search. Anything. We can't predict which it can be used, depends upon the company's person. Semantic search. Either to any of that. Okay.
This
So
semantic search, sorry, semantic search will be used only by LLMs or by search engines as well.
we can use in search engines as well, even if you want to use it in our application while doing the like comparison testing. When the chat GPT, sorry, when we having the chat, when you're asking one question, it gives the answer in one way. Again, if you rerun the question, again it is going to showcase the answer in different way. But both are similar. How we are going to validate on basis of semantic search or cosine similarity. Depends how it will suit for your requirement. You will choose those algorithms. Even in programming as well, like Playwright, or if you are using Selenium, you can use this both and you can make the comparisons.
Okay, thank you.
Yeah. Now after this semantic search, the next era came is like LLM era, where you have already learned what is LLMs, how it will design the uh, like next, how it will predict the next words, and what are the models, which is like a GPT model, Llama, Claude, Anthropic. These are the models which already you know. But the problem with the LLM era is like it can generate the answers. Like, in LLM era, it can generate the answers. But there is a max probability of hallucinations. We are not confirming, just it is giving the answers. There is no ground truth. For some of the way of projects, the LLM will find. But when it goes to companies, they want to give the answer from grounded data. At that time, LLM can't judge that it is coming from the LLM, it is from the grounded data or it is from the vast data from the internet. So it may hallucinate and it can give the wrong results. Then the main thing came is like RAG. After three generations, like these three things, keyword search, semantic search, and LLMLR, we came into the RAG, which is like retriever augment generation. What exactly it will do? In LLM, it will do the guessing part, but here the RAG, the main thing is like it will give answers from the context where we have been loaded. It will give answers from our DB. Whatever the database you have been stored, from that only you will get the answers. Okay, clear till now? That is the best thing in the RAG. So it is not going to hallucinate or it is not going to think out of the boundaries. Just as from the database, what we have been given, from there it is going to give the answers, where you can see that if any of the customer can ask, so where the answers came from, you can confidently say that from this particular document, this page number we have been received. Whether it is correct or not, if you want to cross check directly, we can open the document, checking the page number and cross checking the chunk. It will be clearly visible. Yes, it is coming from the particular data only. So how it will do? So we have the RAG pipeline. So we have to understand RAG pipeline. So what exactly we'll do RAG pipeline? I said DB. We are going to create one local DB. Okay, whether it can be cloud or whether it can be server or whether it can be your PC. If you are making a small kind of rack, you can make your folder as a DB as well. There is no issue. Consider in the DB where we are having PDFs, documents, Excel files, images, and web as well. Okay. Uh, if someone asks the question how web will be coming as a local DB. So for the web, we are having some different extraction strategies. Web crawling, they call as web crawling. Like, let me see. This is called web crawling. Web crawling in the sense, suppose let me open one website, anything. You can consider this. I want to come from this page, I want to extract the data. So I will take this platform dot open, I will extract, I will crawl the data. That is having some separate kind of functionalities in the websites where it will do the entire crawling, where you will get the n number of data, like some thousands of chunks or 200 chunks, 500 chunks of the particular website data. How many, like if you take lg.com. So for that, it took nearly, like there are 1,000 web pages are there. We have to crawl. It took nearly 15 days of time to crawl entire data to store into our local DB. So we can take PDF, doc, Excel. Now what we are going to, we have created local DB. What is our next step? We need to, by directly we are sending the PDF into the machine, it won't understand. What we learn, we have to memorize from first onwards. What we have learned, machine won't understand the complete data where it has to do the chunkings. That means breaking the images into small pieces. The second step is like from local DB to chunking. This is one of the most important thing in the RAG. Chunking is the most important one. So what is chunking? Chunking is like, let me show. So consider this one page. Okay. That means take a screenshot. So how chunking will be done? So right now we are having how many pages of this web page total? 31 pages are there. It's a normal small PDF. Consider you are having 200, 300 documents, 500 pages as a PDF as well. Now how it will do the chunking? Chunking is nothing but breaking the entire document into small pieces. Breaking the small pieces. This is considered as one chunk. Okay. This is chunk one. And this will be chunk two. Like up to this part and rest of this part. 3, 4. In such a way, for one particular document, you have to play like how much it has to be break, how many chunks it has to break, so that we need to make a calculation. On top of that, we will see for one particular document, if you are making one page into 10 chunks, there are 31 pages. Consider 30 pages are there. That means you are supposed to get 300 chunks. That is the exact calculation when we are doing. Okay, when we are making the parsing, so in between that we have one more thing. From the local DB, we used to do the parsing. Parsing is nothing but conversions. There is one background methods will do. By directly it won't do the chunking process. It won't understand anything. So the parsing is nothing but extraction in other language. If you are going for the interviews, they may ask questions like what extraction strategies you will do. Okay, for PDF and doc, there will be normal extraction strategy. While coming with PDF, there are be images will be there in PDF images. Then how the data is going to be extracted. There is separate extraction layer and documents. There will be Excel tables in that one. How we are going to extract. There will be some separate extraction layer. So we have to explain in images. Images is like OCR extraction that is completely separate from whatever the image is there. We are going to extract the text and we are storing it in our chunk. So there are different extraction strategies we are going to utilize while making the chunks. So once the chunks is nothing but breaking into small pieces. So each document, one document, I mean like PDF, it will break into small pieces. We have to calculate when we are ingesting the data. Okay, it is called when we are ingesting is nothing but loading the data into database. Then the parsing is done. Then chunking will start. So on top of that, we have to understand how many documents we have been ingested, how the chunking method strategy has been kept. So how many chunks we are going to get while running our automation to cross check. There is one metric we are checking that the chunk count total. I am keeping that there are 10 or 20 PDFs. While extracting, my number should not be less than 1000 or 2000 chunks. If it went for like 5 or 6 chunks also, maybe some parsing has been failed. Some extraction strategy has been failed. It is not accurate. So we can say there is issue over there. Clear? Now, in chunking, once the chunking is completed, just normally how the data is there, it will be in the same how we have seen. Now it has to convert to embeddings because machine will understand the embeddings, which is nothing but vectors, how we have seen. So each chunk will be converted as a like a vector and it will be stored in the vector DB. How it is we have been shown. So you consider this is one chunk I have been extracted. Now it is simultaneously we have been kept one vector on the side of that we have been stored. Depends upon the companies and the way of strategy. They will use the same DB for that one or a separate DB they want to store. It depends upon them. Now embedding vector, we are going to make it convert into chunk. And here we are going to store it in our DB. Everything we are going to store everything is stored in the DB. The DB outside market, people will use a name is like Pias, Cone, uh, Vector DB, and Chroma DB. There are MongoDB, Elasticsearch DB. There are a number of DBs will be there. So which supports most vector, we can take those one and we can utilize. So people will use like commercial or like free resources as well, free like open source also they can use storing in the DB. So till now everything will be stored in the DB. This is one part. Right now we have been stored all the data. We are storing in DB, chunking, embedding. Again, vectors we are storing DB. Till now it has been stored. Now where exactly it is going to run. Now the second part will come here. Where, how, when it is going to work. Now one user ask one question. Here, one user ask questions. like where you are seeing the chatbot testing. He will ask one question like whatever the query it is like this. Consider who am I? There is one document about like some kind of like self-learning documents are there. From there we have been extracted. They have been asked who am I? Now first thing what it will do, it will be converted into vectors because as we already discussed, whatever the data it won't understand in human language. Again, it is going to break into the chunks and here it won't be break into chunks. It is like normal question. It will be converted into vector. Now completely these are into numbers, some numbers. Now what it will do? It will go for this particular store in the vector DB. Okay, already we are having the chunks. Every chunks has been designed. Consider that we are having 1 to 100 chunks. Now, whatever the question I have been asked in the this vector DB, where it will make the map, it will see the mappings like numbers, which number is nearby. Everything is in numbers, right? Which for this particular data, which data is very nearby using cosine similarity or like top similar. So what we are going to say, we are going to get top k chunks. I will write down. We are going to get top k chunks because we are not going to see all the 100 documents because it's not a keyword search, it's a vector search. So on top of that, which is related to more, I want those 10 top k. Top k means you can keep what are the most relevant data as per the scores. I'm going to get 10 or 5 chunks or 20, depends we want to evaluate. So mostly in the outside market, in the productions, they will keep 5 to 10 in between the chunk size. Okay, to get top chunks. So I am keeping 10 chunks. Okay, now what will going to happen? Now in the top chunks, as I discussed RAG. RAG means retrieval augmentation generation. Once the user asks the questions from this vector database, retrieval start working. Retrieval start working and it will give the top chunks. That means retrieval part is done here. It retrieves top chunks. Out of thousands of data, it retrieves only top chunks. Now, augmentation. What exactly here it will work as augmentation. Now the augmentation starts playing a role. So it is nothing but a prompt in the back they will give. So how we have given the prompting in such a way, they will ask in the prompting to check the LLM whether it is from the context for the given context or not. So from there it will again filter and it will say whatever the top 10 chunks it has been given, 10 chunks it has been given. Again re-ask the question and cross verify, check whether it is relevant to the user, what the question has been asked, the chunk we have been received, relevant or not. If everything is relevant, give me top 5 chunks with scores. It will be displayed here. Now the argument is done. Augmentation is done. Now what is left over? Generation part. Here, this is the generation part. What exactly it will give? We are going to get the top 5 chunks. In this top 5 chunks, again, from this we will say which is having the top 1 chunk. Maybe I am wrong. I will tell you. Yeah. In augmentation, after all the things, it will cross check and it will pick only the top 1 chunk, not all. The top 1 chunk will be sending to the generation. It is going to generate. Like suppose you are going to get the answer within like 4 lines or 7 lines or 10 lines. We are saying in generative, in the generation part, we are going to say that give me the answer in an understandable way, which is very precise and which is very short in 1 or 2 lines. So once the chunk has been taken from there, it will generate, it will give the final answer. It will give the final answer in 1 or 2 lines. This is about like RAG, what exactly RAG is doing in the backend. Any questions do you have? Hello.
Is there any particular method we use for augmentation or like it's just filtering? Augmentation means filtering the nearest answers or
Argumentation is like prompt. In the backend prompt, we are not doing anything. The argumentation is completely the prompt written by the developers.
yeah, from the top 10, how come it comes to the top one? What is the strategy used there?
So again, retrieval strategy. Here, the strategy they will ask the retrieval. They will bring the top 10. In the top 10, again, it will ask the question. The user has been given one question. They have been designed the code in such a way, or the prompt, the method, the logic in the augmentation part. They will design, and where it will work is like, okay, the user has been asked this question. I have got these top 10 chunks. Out of these top 10 chunks, which has the best score? And give me the top three, and it will take again in top three it will filter the best answer and it will send it to the LLM, and from there it will generate the answer as per understanding.
Yeah, okay, got it.
So Jayant, whatever we are using, like Chat GPT or Gemini,
Yeah,
they are not RAGs, right?
those are
They
not
are
right,
just
those are
LLMs,
completely LLMs.
not RAGs.
Those are all LLMs.
Okay.
So
That's why
Uh,
you are
RAGs
going to
are
get hallucination. Yeah.
RAGs are used only for chatbot texting.
Not exactly for chatbot testing. Mostly it depends. Mainly it will be used for chatbot testing. And if you want to get answers as well, like in HDFC, if you ask one question, you will get an answer. So at that time, you can use the RAG. It's not like chatbot you are not doing. Just you are asking one question, it is giving the answers. Some kind of
Yeah,
thing.
basically
But
chatbots only use RAGs, not the LLMs.
yes, yes, exactly. LLM have the capability of hallucination. So that's why we are not using that. But with the help of LLM, the LLM is like a brain. We are using that brain and attaching the rack and saying that forget about the outside world. Just you focus on inside world, which the data we have been given. Use all your capabilities because all LLMs has been trained with a large set of data. Okay,
Hmm.
so they know how to do, how to work everything. Then we are going to utilize the way of brain of LLM and we are keeping the rack attached and saying, this is my data, give me the answers. That's it.
Basically, we are minimizing the data set for in the RAG.
Yes.
so, so RAG is nothing but the local database, right?
Yeah, only local, from the local only. If it goes outside, then it
Local.
won't be called as RAG. It will be LLM.
Okay. So it is mostly used by the all the product companies, right, for their internal purpose.
Not like broad-based companies. Maybe if you consider IDFC First Bank, they have been chatbot. Right now, most of the 90% of the companies are using chatbots. That means they are using local data. See, consider I am having my company. Okay, in my company, I'm not aware of HR details, where exactly I need to go and make a complaint. They will design the rack structure, everything as per the company database, everything has been trained on that. Now they will give it to us. We will make a search because outside it is not going to. It knows only completely from the local, from our company databases. I will ask what is my leave balance. Yes, it will give. It will fetch the data of mine and it will share. Not only broad-based companies, it is utilizing by each and every company. RAG is very mandatory.
Okay. So as you said, see, as you said, chatbot is one use case of RAG. Any other popular use cases for RAG? Chatbot is definitely is a very good use case. Any other use cases, Jay?
Very other means I'm not sure. Mostly it will be used for local. Just you can think of that. RAG is a local database. From that database, you are going to fetch the answers. That's the main agenda because it will
Mhm.
eradicate the hallucinations. Why we are going to eradicate hallucinations? Because I don't want other data and I want to make a restriction. I don't want to combine with third parties. I want to go only with the security things and I want only answers from my database.
Okay. But RAG is very popular these days, right?
Yes, very powerful. RAG is very powerful.
Okay.
So,
I mean, at least if we know, yeah, yeah, carry on. Somebody's asking.
sorry. So if we integrate a RAG with Jira, so what can be the use case? Like we can get any user stories, pull up any st stories, or we can have a like a Git Copilot, right? If we integrate RAG inside the Jira, we can just tell to create user stories. Can we do something like that?
Yes, we can do the same thing. Yeah, we can do that because it will get the data only from your Jira itself. It won't go outside of anything. So from the
Yeah,
database only you are
particularly
going
for
to.
that company only, right? Not outside.
Yes,
So it's only
not
limited to
outside.
that. Yeah.
Yeah, only.
Yeah, I was just thinking that how RAG can be used to make things simpler.
Yeah, if you want to make it, this is one such way you can showcase that by utilizing that. When you are fetching the data from that, you are making sure it is not going outside. It is completely inbound. There is like you confidently say that I am removing the hallucinations. Maybe some people can ask why you are going for RAG. Why can't you go for LLMs? Just you can create LLM. You can connect with the MCP. You can do it right. You can say there is a both ways, but you have to say like to eradicate the hallucination even for that, I am using rack capabilities.
Or also the security reasons you can say you don't want your data to be outside
Yeah,
is
that is also one of the main reason for the rack. So let me show you the rack, how in production it will be like. So as I have designed this one, where is that? Hmm. So it will take more time. So normally in the backend, so how it will looks like. This is the QA layer. Like we are having stages like QA, dev, and production environments, right? So in the production environment, we are not going to show this one to the end user, so they don't know anything. We are going to give it with just removing this one, and finally he is going to get a some chatbot where he will ask one question. He will see whether getting the answer or not. But in the end, how it is going to work? Like the first one is upload. We are going to upload. Here I kept software testing. Right now you guys has been seeing. This is like 31 pages. Okay. Today I will show just how it will work. Tomorrow we will to play with the chunks. How the chunks play a major role. How top K play a major role. How what changes, what will come. Okay. Just I'm loading it. Okay. Permission waiting. Permission. What happened? Yeah. Maybe I have opened right. That side's throwing an error. Okay. I have been loaded this document and I'm keeping next. In reality, they won't showcase any configuration like API key endpoint, but they will give the choice of deployment, which LLM you are using. So I have chosen ChatGPT 4 mini because the companies will be there. You are having n number of customers, n number of clients, each customer having different mindset. Some people used to pay large set of amount of money. They are ready because they want the technology, they want the outputs, they want with zero errors. Some people want to has the work done in less cost. So they will choose. When you click on this, there will be a drop down. You have to select a number of things. And the next one is embedding deployment. So we have seen now we are seeing here it is getting embeddings into vector, how it is going to convert because This is the one which will convert everything into the vectors from this model. Now let me add the data API key. Now let me run it. So this is the one where you have to play a lot. Okay, if you want to see the answers properly and it is coming correctly or not, and how the chunking has been went properly or not. So you have to play n number of times. You can say just I'm keeping the default size 200, chunk overlap, top K. It will showcase. They can keep 5 or 10, but I used to keep only 5. Temperature, which is nothing but randomness. So how dynamic your answer has to be. Like suppose if I say, if I keep 0, that is the standard one. N number of times if you hit the query, you are going to get the same response. If you keep it as 1, it will change dynamically. Right now you got one answer. If you hit again, it will get the another answer. 10 times you hit, 10 times you will get a different answer, but the same meaning. It may wait for hallucination as well sometimes, because if we increase the temperature more. So we have to play right now. Let me keep 500. The chunk size is nothing but here the characters, not the tokens. Here the tokens is like the same one. These are tokens. Yeah, there's some terminals will be different. Okay, I'm just clicking next. What we'll do? We have to index. That means we have to train. In the backend, it has to get parsing, it has to get convert. It not yet. Everything is not yet started. We have to make the conversion of chunking. I just start indexing. I click. So the indexing has been started. If you are doing in the backend, you have to see it's processing or not. See, it's processing. Again, from our understanding, we are keeping that. So totally 96 chunks are there because I kept only 500 chunks. So that's the reason it has been calculated and we are getting 96. It will take some time to get processed. In reality, when you have been large set of data, when you are training, the indexing may take literally for 1 week to 2 weeks. In some of the cases, it may complete like 1 or 2 days. If small data, it may complete within 1 or 2 hours. It may take lots. Once it has been indexed, nothing to worry.
So indexing
Yes.
is nothing but keeping all the chunks in an order, right? One, two, three, four. Chunk one, chunk
Uh,
two, chunk three, like that.
it is like we are, as I told you that there is a PDF document. I am breaking all the documents into DBs. Either I'm converting into vector DB at the same time storing into the normal DB as well. Both everything will be completed in indexing. It will store.
Sorry, you said converting into DB?
I mean converting into vectors and
Yeah,
storing into DB.
okay.
But these concepts are really new, actually, completely new.
Yes, if you understand the concepts, you can play well with the AI because in reality, whatever the persons are interviewing the questions, they don't know this much. Okay, if they ask something, you can re-ask them if you know this one or not. Then definitely they don't know. They don't know the concepts. They are just falling running on the AI tools.
How does this
Mhm.
indexing happens? Is there any particular process of doing indexing? Like similar chunks are indexed together?
These are the queries now. Like we have everything in the backend, right? It will do the generation. Like from there, it will run. Everything in the backend, code. So
Mm.
this is the where if you are hitting indexing, that means it is running somewhere. So
These
from
are
where
all
you are running,
Python codes?
everything
Python
is
code.
Python. Yeah,
Okay.
yes. So
Can
you
you
can
share
see
all this because I just want to just go through how does it?
so this is the code.
Chad, is it like if we keep the chunks higher, like for example, you said at 500 or we can give 200, is it
Yeah,
that we get more accurate answers if the chunks are more or how is it?
Yes,
Exactly.
if you are keeping the chunks number more, that
Mhm.
means you are getting the data. You are breaking the data into small pieces. Either small pieces will won't give the answers, either more number of pieces also won't give the answer. So we have to understand, we have to play. That's why I said we have to play with the chunkings. So keep 200. Ask the question, are you getting the proper answer or not? Increase to 300. Check are you getting or not. See how it is coming. I have given the chunks 500, right?
Yes.
Yeah. Now I'm keeping. See, chunk is nothing but characters. For it, it should not cross that 500. It has to be less than 500 only. Characters. Each chunk is nothing but the characters. Complete characters, it has to be 500, right? And you can see we have to cross check this one also. If it fails, it fails. See, for it should
So
not cross
confirm.
500. That is also we have to test while doing testing.
So is it
Okay.
like you have to check it manually, everything, all the chunks?
Not manually, madam. Just we will cross check 4 to 5 chunks. That's it. Not required
Okay.
because if you see there are 96 chunks. I
Correct.
have
That's
kept
what.
top 9 only because not required. In real time also it's not required. We will see whether the chunks are generating, how many chunks has been generated. In reality of the production, they may keep pagination will be there, like next page. How many chunks are? We randomly we will see 2 to 3. If something we have been caught, then it's an issue. Normally we won't find any issues because you can see the text is getting chopped off in the middle. Okay.
Mhm.
Then we are going to keep one more metric as I have been kept chunk, what is the chunk size? And before that, one thing will be there. It will add the data when is the proper testing is not going. Some text is cutting, chopping off. We will add it. So tomorrow we will discuss more on that. So I have been done the chunking. Total 96 chunks are there. Now I'm going for next one. What is that query? Okay. In the testing, we can ask any question. Okay. Uh, what I can ask, what is the
Ask the sub what
SD?
who will do the testing.
Yeah,
Okay.
you can tell me any question. Let me see.
Like who we are just testing, right? Ask like who will do the testing. I have seen like four answers: developers, managers, lead, and
It won't. I already told from the data only it will take and it will give the answer. See how it came.
yeah, yeah, correct, correct. Software
Testing will be
testers.
done by software testers, software developers, project leads, managers. It is giving the answer, and this is called citation. These are very, very important. Once you are getting the answer, you need to make sure from which chunk it has been giving the answer. Okay, this is chunk one. Now we can see, copy it, whether the chunk is in limited or not. The characters, yes, perfect. It is within the limit of 500. It is giving the correct. Now, RAG is up to this much. Okay, getting the answer, the chunk and answer citations are not. And next top of that is like ragas. You see, evaluation. Tomorrow we are going to discuss on ragas and we will make the hands-on expertise like how to tune, like if we keep the chunking to 200, how it will look. If we keep 300, how the answer will come. Everything will be, we can discuss more. Till now, any questions do you guys have? Do you got any idea what exactly rag will do? What chunking will do?
So one more last question, JNC. If we have more chunks, and then
Sorry.
if we ask any, if we have more chunks, suppose if we
Uh,
have 10 chunks, and
okay.
if we ask one question,
Hmm.
then it is easy for the system to quickly check all the chunks and retrieve the answer. And suppose if we
No.
have like 1,000 chunks,
Yeah.
do you don't you think? I don't know anything, but I'm just asking. Like, don't you think it will take a lot of time? I mean, will it not impact the performance? I mean, it has to check all the chunks, right?
Hmm. Yeah, you
Is
are
it so
forgetting.
or
You are thinking from the way like keyword search. If you are doing the
uh,
keyword
uh,
search, what you are said is yes, I will accept that. But you are doing embeddings. What exactly embeddings is doing? I said we whatever the question I have been asked, it will be converted into that like sorry, embedding vector search, where it is converted into the numbers, everything in the numbers. Now these numbers will
Mm-hmm.
search. Already we have been chunks. The chunks has been divided into again the vectors only. Now it will check with the vectors. What vector is nearby? It will make a search and it will give the top 10 most chunks which is relevant to this, which is having the nearest algorithm. Okay, there are two types of search will be done, distance and similarity. So some people will use distance, some people will use similarity. So if we using the distance, the lower distance in the this algorithm will take and it will provide the score. Okay,
Okay.
where you can see the score. The chunk one is has the best score 0.003. That means here we are using the matrix is lowest distance. Okay. And coming to similarity, better match will have the highest score. There is a difference. You will get confused. Okay.
Yeah, yeah, already confused a little bit.
Okay. Okay. Then I will stop it here. Okay. No issues.
So
It's
I'm just
like
thinking in terms of the performance, okay, will
performance,
it be
okay.
quick or
Yeah,
not?
I will give you that answer. Even when we are doing that, we will run the performance testing as well in the back end because when
Oh,
I'm
okay.
getting the answer, we have to see as per the SLA agreements, the answer has to come within 10 seconds or 15 seconds. When there is large set of data is there, as you said, it may went for lag, like 20 seconds, 15 seconds lag will be there to give the answers. So they will do the fine tuning. That is different concepts. They will do that fine tuning and they will give the answers. They will break it. They will keep agents or like they will keep multi-rag agents, retrievals, concepts. There are a number of things while you want to do that.
Okay. Okay.
Uh, so what will be a QA tester's role in RAG, basically?
Same. We will see the chunk, top chunk is coming or not. What is the score? Is it relevant or not? Because mostly what exactly we will do is like we will do the randomly, we will pick 10 to 15 cases, not completely we can't do because there will be like n number of documents. So consider that there is 1 lakh documents. From there you are not going to test all the data, right? So you will pick randomly, you will search the application log, you can go with the document, PDF document, you will read, understand some of the part, what exactly, or else you will do something. Take that entire document and give it to ChatGPT and you will ask to give the correct questions and correct answers. Okay. On top of that, you will keep how we are kept in the LLM as a metrics for that one question expected data, actual data. You will keep that one. In the chatbot testing, that is what we are going to do. We will keep the question, answer expected. Now we are going to fetch the answers from here, from the chat window, and we are going to make a comparison by using similarity search or cosine similarity. I mean semantic or cosine similarity. We will do the comparison with the threshold value, keeping that the score has to be not less than 0.8.
Basically, the metrics what we get from the LLM evaluation, we are cross-checking with the RAG score. That's
Yes.
what you mean?
Not like that. The LLM evaluation is different. Here, what exactly you have been asked is like, if we are running in the chatbot, how we are going
Mhm.
to validate the answers, right?
No, I'm saying that suppose in a company they want someone to
Hmm.
take care of the RAG, right? Any testers. So what kind
Hmm.
of like a database testing role for a QA? Can we have an RAG testing roles? You can say or vector DB testing roles.
Okay, it won't be like not vector DB. So if someone asks to do the vector DB, so we will see the chunks has been generated or not. So the chunks has been generated. Now for that relevant chunk, the vector DB has been generated or not. See, if it has been taken from here, where is that? You have seen this chunk, okay, called chunk one. This is chunk one. We will see, this is chunk one. Exactly, it is the one or not, it has been extracted. We will see if it is extracted, the same chunk it has been generated. Yes, it is correct. If not, it is wrong. We will check that one.
So we are going to check it manually for every record,
Yes,
for
yes, it will be
every.
manually only.
So you don't have like in SQL, how do we have queries to extract from?
You
Can we
can't
do?
check. Here you are seeing only 10 chunks or 20 chunks. In production, you are going to get some thousands, 10,000 chunks will be there. Then how you are going to check all the data? You can't. Randomly, even in the reality also, randomly we will pick 100 chunks. Randomly we will take it, the data. We will take it, and if you want to do the testing, 10 to 20 chunks we will make it, and the DB will cross check whether the embedding vector has been generated. There will be some conversions. If the embedding is there, if we convert, it should come into the same meaning, that text it should be. We will test that one from my knowledge. If it is not the case, how we will do? Here I got the answer. We will take the questions, all the questions, and we will keep the expected answers. Okay, now I am going to generate it. Now here I will see the answer. I will make a comparison with two of the actual and expected by using the cosine similarity search or similarity search.
Okay, okay, got it. Yeah.
Yeah, okay then. Any more questions, girls? Or else we can wind up and tomorrow we can clear our rest of the doubts by understanding more.
So again the RAG only. So we can use this concept in Zira also, right? I think somebody else was asking the same question.
Yes,
Why?
yes,
Because
we
in
can use.
Jira we have so many user stories. We keep
Mm,
working, and
mm.
suddenly some functionality comes, and we don't remember anything. So as of now, there is an option in Jira to search with the keywords. Even Jira will try to fetch the related user stories to the best of its ability. Okay.
Mm.
Um, but like can we really implement the RAG concept in Jira, and can we keep all the user stories for the last 3 years or 4 years? And can we is it like feasible?
Feasible in the sense, simply we can integrate that. We can integrate
I
with the
mean,
RAG.
same. Hmm.
Yeah, if we integrate the Jira with all the access, complete data is into that. Once you have to train the application completely, then on top
That is
of
what.
that,
That is
you will make a query. The chunks will be generated, everything will be generated.
But I think this will be done by the developers, not by us, I think.
We don't need to do anything. Developers will be do. Instead of that, you guys can create, integrate the MCP with AI. So it will work more instead of this RAG.
What the
okay. So when you
MCPs
say
does, like if we have a Jira MCP, can you just explain about little bit about MCPs in the next class, coming class, like how we can use those?
Yeah, I will try my best to explain. MCP is like an integration tool, totally like we are just integrating from one that from like if you are having Visual Studio, your code is having this, and you want to integrate your code with Jira. Normally, if you want to integrate, you need to get the APIs, and there is some no, a number of stuff will be there. So to make it fees, there from we are going to fetch only one API will be there in the Jira. We are going to call that API. From there, it will understand rest of the data. We have to give the permissions. Then it will do the rest of the thing.
But I think for using Jira MCP, we have to pay, right? It's not open source.
Yeah, it's pay only, not open
Yeah.
source. We have to pay for it.
yeah, yeah. Thanks, Jayant.
Yeah. Thank you guys. Thanks for your time. Tomorrow we'll
Yeah,
meet.
thank
Yeah,
you. Yeah.
Thank
yeah.
you.
Thank you.
Yeah, thank you.